Okay, so let's look at that first polynomial, or that first addition problem we have here. We have two polynomials. The first one, what could we classify that first polynomial as? I want you to name it. What's its name? Everybody come up with a name for the first polynomial. And I don't mean from your favorite, nameless, like Henrietta. So what's the name of that first polynomial? So we're kind of reviewing for the quiz when we do this. Faith, what's the name of the first polynomial? Okay, engage here. Thank you. Tori, what's the name of the first polynomial? Cubic. Because it's cubic because it's degree 3. Okay. It's in standard form and the largest exponent is a 3, so that means it's cubic. And then the next name is based on the number of terms, and I think you kind of tried to say binomial maybe, but binomial means how many terms? 2. So Noah, what is its other name?
Trinomial.
Yeah, it's a cubic trinomial. Okay. How about the other polynomial? What's its name? Michaela? A quadratic trinomial. So we have 2 trinomials, but one of them's cubic and the other one's quadratic. That says right there, as soon as you can name them, and they don't have exactly the same names, that says right there that you're going to use, when you use the vertical format, you're going to have to use placeholders. Something's missing somewhere. If you use the horizontal format, do we have to use placeholders? No. Okay, so the vertical format, let's start with that one. Let's get it set up for that one. First of all, we're going to rename them, getting rid of all of our subtractions. So go ahead and do that first. Rename the polynomials that we have as our terms of our addition problem. Once they're renamed, now we can get them moved and set up. Now tell me, in the cubic trinomial, that tells me if it's cubic, if it had every term it could have, if it's a degree 3 and it has every term it could possibly have, how many terms would it have if it's cubic? What do you think? How many terms would it have if it's cubic? What's the most number of terms it could have if it was simplified and it was cubic? 3? Like it has? 4? 5? Okay, I don't think you're quite engaging here, nor are you understanding what I'm even asking. Okay, in standard form, if it's a degree 3, what would the first term's exponent be on the variable? A 3. So the next term, if we had every term we could possibly have, the next one's variable would have what exponent? If we had every single term, the next one's variable would have what exponent, Aurora? No, it's right here. I already have that one. 1. And if it had every single term, what would the next one's exponent on the variable be? 0. So how many terms could it have? 4. Does our cubic trinomial have 4 terms? It's missing one of the terms, isn't it? Which term is it missing? The 0. Oh, I don't think so. Because x to the 0 power is x to the 0 power is what? I can't hear you. Clarence, I'm going to turn my hearing aids down. You're just blowing me out of here. X to the 0 power is what, class? Oh, I quit. Can't take it anymore. Well, I see you.
Does mean no more algebra class?
X to the 0 power is. I get paid way too much for you guys not to know this. Come on, seriously. 1, thank you. Oh. Did you say I said that? Maybe I should be able to hear you then. This is always what I hear after the fact. I said that. Well, then how come I didn't hear you? Okay, x to the 0 power, every single one of you in here should have been able to shout 1. Are you kidding me? Are we back to that? You don't even know what x to the 0 power is? Okay, well, x to the 0 power is 1, and 1 times negative 3 is negative 3. Are we missing the term that has the x to the 0 power? No. Which term are we missing? To the first power. Oh my God, I think I'm finally making my money again. Okay, here we go. 2x to the third power plus x to the second power. We're missing the x to the first power, so what are we going to put there? Our placeholder 0. And then we're going to put plus negative 3. All that for that. The next trinomial is a quadratic trinomial. What's the most number of terms a quadratic could have if it had every term and it was simplified? Quadratic is degree 2. The next term would be a 1, and the last term would be a 0. So it could have how many terms? 3, and it has them all, doesn't it? Yeah, it has all of them. So because it's a quadratic trinomial, it can't even have that cubic term, can it? So we just put a 0 here. It can't have that one. It's quadratic. And now we line up our... Now, if it helps you, if this is more useful for you, you're like, having that 0 in the middle there just kind of confuses me. What could we put behind that 0? An x. Go ahead. I mean, because 0 times x is still 0, isn't it? So your placeholder can be a 0x instead, if that makes more sense to you. And now we're ready to add these guys together. Okay, go ahead and add, clean up, and circle your answer. And the cleaned up answer is what? You got Faith? You're not writing anymore. You must be ready for me.
2x to the third plus 5x to the second minus x minus 2.
She's got it. Good job. Okay, there's our answer for that one. Okay, now, when we do it horizontally, we should get the same answer, right? Okay, when we do it horizontally, does all that song and dance I just went through matter? Do we need placeholders? No. So what are we going to do? We're going to, since we've got it all written as addition, we get to just drop those parentheses and write it all down, don't we? 2x cubed plus x squared plus negative 3 plus 4x squared plus negative x plus 1. They were both trinomials, so 3 terms each. 3 plus 3 is 6. We better have 6 terms in our addition problem here. 1, 2, 3, 4, 5, 6. Okay. What's our next move in horizontal format? Group them. Put the like terms together. So go ahead and start doing that. And when you're grouping, your brain should say standard form. Standard form. What would be standard form? 3, 2, 1, 0. Did I just hear blast off? Okay. So the 2x cubed doesn't have anything to be combined with. The x squareds, oh, isn't that amazing? They become 5x squared. The negative x doesn't have anything to be combined with. And negative 3 plus 1 is negative 2. Cleaned up. We get the same result. Okay, so again, say, I believe, even if it says you have to do it one way or the other, we're on our second day of it, I'm gonna let you choose. What do you wanna do? You make that decision. What would be the best way to do this one? Because are some of them actually easier to do horizontal than they are vertical? What do you think? Can you give me an example? Be as crazy as you want. Can you give me an example of an addition problem of polynomials that you look at it and you'd be like, oh my goodness, I would never want to use vertical format on this one. I got one for you. I bet you could think. You got one for me? Anybody got one for me? Okay. You want to use vertical format on that one? Why not?
Don't have any like terms.
Okay. Don't even have any like terms, let alone, yeah. And then, how many placeholders would this baby need? It's missing to the 8th power, it's missing to the 7th power, it's missing to the, I mean, does it need a few placeholders? Does that one need some placeholders also? Yeah. Would this be would vertical format be an efficient way to add these guys? Not at all. Not at all. Horizontal would be. And then the answer, I bet you already have the answer. What is it? But you can do this in your head. This is what? What's the answer to that? Devontae?
X to the 9th plus 3x to the 4th plus 2x minus 7.
You got it. See, that would not be very efficient to use the vertical format on that one. Okay, now let's take a look at the next one. What's different about this next one that we haven't had so far?
It is adding and subtracting.
It's adding and subtracting because it has how many polynomials?
3.
It has 3 polynomials. Okay, so let's first just take care of what do we take care of first always before we try to do too much? Add the opposite where? Within the parentheses, within the polynomials themselves. So let's go ahead and rename just the polynomials. Now, are we ready to set it up for our vertical format? No, because we have,
Well, we have to change the subtraction.
yeah, because here's the cool thing. If we change it to addition, then all 3 of them can be added at the same time. If we don't change it to addition, what does order of operations say you have to do first? Would we do the subtraction first, or would we do the addition first? Subtraction. You add and or subtract from left to right. So we'd have to subtract first to get that answer, and then we'd have to add. We'd have to make it into a 2-part problem. Whereas here, if we change it to addition, it doesn't matter. We can just add them all together all at once. So does this one get renamed, the x squared plus negative 1? No, leave that one. We want the subtraction to become addition. What's the second polynomial's new name now?
Negative 3x plus negative 2.
Negative 3x plus negative 2. Every term of that polynomial has to change to its opposite. How about the third polynomial? Are we going to rename it? No. It was addition in front of it. No need to rename it. Okay. Now, especially when there's 3 of them, here's the thing to do. Look at all of the polynomials and say, what's the degree of each of them? So what's the degree of the first one? Degree 2. How about the second one? Degree 1. How about the third one? 2. Okay, so here's the deal. We know we're going to have to start with some x squares because the highest degree of all 3 of them are the squares. So now we'll start with, we'll say x squared And then, should we put a placeholder in here or not? Is there anything missing in this one? Degree 1 is missing. The x term is missing, isn't it? X to the first power. So we're going to put a +0 or a +0x, whichever works better for you. And then our last term, our x to the 0 power, which of course we don't get to see because it's just 1 and it will make it constant anyway. So our first polynomial has that placeholder. Okay, how about our second polynomial? Any placeholders needed there?
Yes. Zero.
It's missing the x squareds, isn't it? So we would say 0x squared, or just 0 if you want, plus -3x plus -2. In other words, we have to have columns of like terms in vertical format, don't we? How about the last one? Any placeholders needed?
Yes. The last one.
The last term, right? We're missing the constant term. So we'll put our 2x squared in the x squared column, our -4x in the x column, and 0 in our constant column. And now we're ready to add. Okay, go ahead and add those together, clean it up. Check me out when you're done. Or just change your answers, I can make mistakes. I didn't eat a good enough breakfast today. Chances are I made a mistake. Any challenges? You like my answer? Okay. Horizontal format then. We've changed it to a straight addition, right? So we can just drop those parentheses and start writing down all those terms. Do we need placeholders? No. Maybe that's why some others like the horizontal better. We don't have to do those crazy placeholders. But you need to have if you're using horizontal, you need to especially have a method to make sure you don't leave any terms out. So first of all, I should have 2, 4, 6 terms. 1, 2, 3, 4, 5, 6 terms. Don't leave any out. That's one of the hazards of horizontal. The next hazard is when you're regrouping it, something happens. Okay, so we need to. So sometimes what helps students is going like this. If I take the x squared and bring it down, maybe just put a little slash through it. So you can still read it. Don't mark it out so you can't tell what was there. And then go through the list and say, oh, there's some more x squareds. And now there are no other x squared, so there's one of my groups. And then standard form, what would come next? The x's or the constants? The x's. So then I would say, okay, well, I got that -3x. That's going to come next. And do I have any other x's? Yeah, I got some more at the end there. So those guys are going to get, but no others. So they're going to become their own group. And then I have my -1 and my -2. They're going to become their own group. So you kind of just, mark them off. Like multiple choice answer bank. I've used that answer. Not going to use it again. And we should end up with the same result, right? So go ahead and finish it off if you haven't. Okay. Any questions? Again, you get to decide, even if the directions in the homework say, use vertical format for addition. If you get to override it. You can say, no, I like horizontal better. I'm going to use horizontal for this one. You need to override it. Okay, let's go to the back side. We have a challenge problem to do. I don't know if we can handle it. We don't even know what x to the 0 power is. Can we challenge ourselves to solve this equation? Huh. It's got some polynomials in it. How many polynomials does it have in it? What are those two, Aurora? The ones in the parentheses? So does that mean this guy's not a polynomial because he doesn't have parentheses around him? Wouldn't it be a monomial? Yeah, this one actually has 3 polynomials in it. It has a monomial set equal to the difference of 2 trinomials. And so we really actually, it was kind of a trick question. You know, I didn't see parentheses, so I was thinking that might end up happening. So, you know what, we're not gonna worry about this b squared over here for a moment. We're just gonna say, you just keep coming along. Okay, so b squared is just gonna stay b squared over there. That monomial is gonna get kind of just drug along here a bit. And we're going to treat this as we have a subtraction of polynomials. Now, we get to use vertical format or we get to use horizontal format in our work. So you go ahead and decide after you get these renamed. First of all, we got to rename just the polynomials themselves within the parentheses. And then that b squared that's going to keep coming along comes down again. And now we'll rename not the first polynomial, because we never renamed the first term of a subtraction problem. We renamed the term that was being subtracted to add the opposite. Once we have that step done, now we can kind of like, you know, either put a huge circle around that b squared if we're going to move on to vertical format, or put a star by it, or make sure that we say, you know what, I'm not going to forget about you, I'm coming back for you, but I'm going to just kind of like, you know, veer off and do some vertical addition if you're going to do it that way. If you're going to do it horizontally, then it can just kind of like stay with it, okay? So I'm going to do it horizontally. If you want to do it horizontally with me, you can. If you want to veer off and do your vertical, go ahead. So I'm going to drop my parentheses first of all. And no matter how much that b squared begs you right now to move over and work with these other guys, just say no, stay where you're at. Leave it alone. Don't let it move. It's going to stay there for the moment. And then you will start your grouping. So 3b squared plus negative 2b squared. That takes care of these guys. No more b squareds. Okay. Got some b's. Those b's can look like 6s, so if, you know, if all else fails, your b's and 6s look too much alike, change that b to an, change the b's in the whole problem to an x if you need to. Okay, what's the right side become? What's this side become? What's our... Thanks for joining us, Abby. I love it. Okay, b squared. Negative 1b or negative b, it doesn't matter. Okay. Plus 9. Okay. Do you guys agree with Abby? Abby, to the rescue. Where were you when we were asking what x to the 0 power is? What is x to the 0 power, Abby?
0.
No.
No, nothing.
No. Oh, I put you on the spot. Yeah, they'll say the answer because it took us a while to get it. Okay, anybody have any suggestions for how we're going to solve this? It's a challenge problem. Challenge yourself. Suggestions. How could we solve this? Julia?
Couldn't you move something to the other side?
Couldn't you move something to the other side? Sure you could.
Like subtract
We got b squareds on both sides, right? So maybe we could move them up one side or the other. So maybe thinking, you know what? Which side did you want to move them off of, by the way?
Like, subtract b squared from the right side.
Subtract b squared from the right side because then it would disappear over there. Just for some reason, we just want it to go away. And then if we do that over there, we got to do it over here, right? Okay. Is this legitimate? Can we do this? Are we doing anything bad? Or something that we can't do? As long as we do the same thing to both sides, can we get away with it? What's b squared? Take away b squared over here. 0. You know that poor 0? You guys are just shaking your head like, I don't know what to put there. It's like 0 doesn't matter. 0 matters a lot. It's on the number line, is it not? So 0 equals, well, this becomes what? What's this become? 0. Now, because there's other things on this side, do we really need to put that 0? No, because there's other stuff there. Over here, there wasn't anything else, so we have to put the 0. We have to. Here, we can, or we can just say, you know what, it's really useless. Because 0 plus those guys will still be those guys, right? Okay, what's next? What should we do next? Subtract 9 from both sides, okay. Subtract 9 because this guy's useless, so we're just going to ignore it, right? 0 take away 9 is negative 9. And what's left over here? Negative b, okay. We done? We have to divide by negative 1 because we can't leave it a negative b. We have to make it a positive b. So, since there's really an invisible 1 in between that negative sign and that b, so now we have a negative divided by a negative is a positive, and 9 divided by 1 is 9. And looky there, we did it. B equals 9. Now, I just curious, could we have saved ourselves a step over? Go back up to here. Could we have saved ourselves a step of work? We made it into 2 more steps. Could we have just made it into 1 more step? No? What could we have done instead of subtracting 9? Because what's the goal? The goal is to get the what by itself? The variable by itself. Doesn't matter which side the variable is by itself on. No. So what could we have done instead and said, oh, I'm done now. Noah?
Added b to both sides.
We could have added b to both sides. If we would have added b to both sides, 0 plus b is b, and this would have canceled out, and we would have had 9. Look at there. There's another. Did we get the same result? Yeah. Just like, you know, we're into saving ourselves work sometimes, right? Okay, let's